Now for another movie. This is exercise 4 of chapter 7. And earlier in this chapter, I introduced you to creating movies and data animations using geometric transformation of points. And yeah, now we're going to do a little bit more. Here you can see the transformation matrix. So here, this is dependent on a variable phi, and I define phi to go from -1 to +1 as a function of the time step. So phi can start off at -1 and then it gets bigger and bigger over time, and then eventually it ends up at +1. And then creating the points is very similar to what I showed in the previous exercise, just plotting it in a slightly different way. So here I'm plotting the cosine and the sine separately, as opposed to plotting cosine by sine, which creates a circle. So lots of ways you can do this. And in fact, when I switch to code in a moment, I'm going to show you some different ways of defining this variable phi that make this animation a little bit more interesting. Okay, so now I'll switch to Python and show you my code solution. Earlier in this chapter, I explained how to set up and use these animations. Basically, we need to create a function that updates the plot at each time step, and then we call that function, and then that loops over all of the time points. Okay, so I call this a frame, this function, because it defines a frame. Let's see, here's the transformation matrix. You can see looks kind of similar to the previous transformation matrix from the previous exercise, but now this is dependent on a variable, which is the input into this function a frame. So that means that this transformation matrix is going to change each time we run through this code. Okay, and here you see the same code that should look familiar now from the previous exercise and also from earlier in the chapter. So we take this transformation matrix, we apply it to the cosine data points and the sine data points. So I call that P1 and P2, points 1 and points 2. And then we update the X locations and the Y locations in these plot handles. And if this doesn't look familiar to you or you don't know what's going on, then no problem. It just means that you need to refresh your knowledge from earlier in the chapter where I explained how to set up this animation. Okay, so that's the function that gets called at each frame. Each time Matplotlib will update the video frame. And here you can see I'm defining the XY points. This will also look familiar. Here I have theta, so the angles, and then I have cosine and sine. Now, in the previous exercise, I actually didn't allow this to loop all the way around and have a redundant uh, angle at 0 and 2 pi. But, the higher resolution you get, the less it really matters if there's a little uh, uh, overlap in here. So, and just maybe I was lazy when I was writing this line of code. Anyway, then here is where I define phi. You can see this goes from -1 to +1, and here I am actually tracking it off, although I think that's really not necessary in this case. But you can see, the important concepts here are the linear algebra stuff, the geometric transformations, updating the transformation matrix, and so on. All this other stuff is just a matter of personal preference. Okay, anyway, here is the function, the method that calls the function with this figure, this function that we defined in the previous cell, and then the variable. So let's run this to generate the movie, and it's quite big. So I will zoom out a little bit. Okay, so here we can play, and you can see that the transformations are being applied at each step. So we get like a nice little animation here. Okay, now, so this was the values for phi that I wrote in the text, but actually, I'm playing around with this a little bit more. I like this kind of stuff, so I keep working on it. And I found this function that I like. So now I'm going to rerun this. Just a different way of defining phi. You can see it is still -1 to +1, but then I square it. So now it's going to be a quadratic function. And then I say 1 minus that, which inverts it. So it's going to look like this. And, there's no kind of meaningful theory. I'm just playing around with this stuff and I find values that I like, and that ends up looking like this. So it's kind of like bouncing, coiling DNA thing. Okay, and then here, just to show you what that vector phi looks like. So you can see it was a quadratic, but then I subtracted one, and now it is also quadratic, but it opens down.